Over a span of approximately 26,000 years, the Earth's axis traces out a circular path, much like the slow rotation of a spinning top that's starting to lose its balance. As Earth undergoes axial precession, the orientation of its axis changes relative to the background stars. This phenomenon has several consequences, one of which is the shifting of the position of the North Star over long periods of time. While Polaris is currently our North Star due to the Earth's wobble, in about 13,000 years, another star, Vega, will take on this role. The place in the sky that the Earth's North Pole points to also changes slowly over a vast amount of time. Researchers call this movement's teleprecession. Polaris, also known as Alpha Ursae Minoris or Alpha Mi for short, is a moderately bright star, the 48th brightest star in the Earth's night sky, that has a slightly yellowish hue. Its location near the celestial North Pole allowed sailors and explorers to establish true north, crucial for charting courses and navigating across oceans and uncharted territories. So friends, back in 3000 BC, a faint star called Thuban in the constellation Draco was the North Star around the same time the Egyptians built the pyramids. It wasn't until about 500 AD that Polaris became the North Star. As time passes, it will move closer to the Earth's North Pole until it is directly above it sometime in the year 2102. Then it will start to move away again, but remain the closest star to the North Pole until 3000 AD. The sudden question might arise in your mind that how do I find the North Star? Well, that all depends on where you live on planet Earth, as in some places it cannot be seen. The constellations, those groups of stars in the night sky that resemble earthly objects or mythical figures. So now we're going to make you an expert at finding a couple of these constellations and thereby locating the North Star so you can impress your friends and family. There are a couple of ways to find the North Star. The first way is to locate the constellation known as the Big Dipper. This constellation has the distinct shape of 7 bright stars that resemble a ladle or a scoop. It is actually quite easy to find, and most stargazers can identify it quickly in the night sky. For some of you, you may not be able to see the North Star because there are regions on the planet where it cannot be seen. As one moves southward from the equator, Polaris appears lower in the sky, eventually dipping below the horizon. At the equator, Polaris is right on the horizon, making it impossible to see. In the southern hemisphere, Polaris cannot be observed at all. Now, here's something really interesting that you cannot see about the North Star without a telescope that many people don't know. Polaris is actually part of a multiple star system. The primary star, Polaris A, is a supergiant with 4.5 times the mass of our Sun and has a diameter of almost 28 million miles. Astronomers call this star a Cepheid variable, which is the closest of its kind to Earth at about 445.5 light-years away. A Cepheid variable, also called a standard candle in astronomy, is a type of star that pulsates radially and varies in diameter, temperature, and brightness. The magnitude of Polaris makes it the brightest star of the triple star system, making it easy to see with the naked eye. Its 2 smaller companions are named Polaris B and Polaris AB. Polaris B, a main sequence star, orbits the primary star at a distance of about 2,400 astronomical units, while Polaris AB, another main sequence star, orbits at a much greater distance of about 18,000 astronomical units, so you're going to need a good telescope to see them. As far as the North Star is concerned, there are some pretty amazing real images of Polaris. This image was captured by the Chandra X-ray Observatory, NASA's flagship X-ray telescope, and what it imagined was breathtaking. Now, if we start to zoom out on this image, we get to see the North Star's surroundings in amazing detail. Those are not earthly clouds you're seeing, but what is called an integrated flux nebula that is mostly composed of dust particles, hydrogen, and carbon monoxide, among other elements. And this image gives us an even clearer look at the nebula that appears to surround Polaris. But the surprising thing is that even though it looks like it's surrounding Polaris, it is actually located behind the star, far away from the galactic plane. Now, here's an interesting thing. These integrated flux nebula are illuminated by not just a single star, but by the energy from the integrated flux of all the stars in the Milky Way. How cool is that? So now that you have a Destiny Master's degree on Polaris, the North Star, let's see what the big news is that suddenly has a lot of astronomers talking lately. They say that there is something strange going on with the North Star because researchers seem to be having a problem when it comes to measuring just exactly how far away Polaris is from Earth. It turns out that the North Star is very difficult to study and keeps breaking astronomers' models of how stars are supposed to act, and we can't really pinpoint exactly how far away it is. Astrophysicists have a few ways to calculate the mass, age, and the distance of stars in the universe, such as Polaris. One of these methods is called the stellar evolution model. With this, researchers study the brightness, color, and the pulsation rate of a star, and then use that data to figure out how big and bright it is, including what stage of life the star is in. When researchers get that all figured out, they can tell how far away that star is from us. This model is especially precise when it comes to Cepheid variable stars like our North Star because their rate of pulsation is directly related to how bright they are, making it relatively easy to tell the distance to these types of stars. Now, when Polaris pulsates, its brightness varies because it physically gets bigger and smaller, which has to do with helium in the star's atmosphere absorbing energy. Naturally, when the star gets bigger, it's brighter, and when it shrinks, it dims. The variable nature of Polaris was first discovered back in 1911 by Danish astronomer Einar Hertzsprung. Observations of Polaris since then show that the star has had a consistent pulse period of 4 days. But this has recently begun to change, and now astronomers are wondering why this is happening. Now here's the strange part. For more than 150 years, and up until 2010, the pulsation periods had been getting longer by about 4 to 5 seconds each year. Now, for some reason, this trend has reversed, and no one is quite sure why. There are more shocking clues in the depth of this discovery, but what do you think about these details? Mention your thoughts in the comments section. If you liked the video, then hit that like button and share with the space enthusiasts. And subscribe to our channel for more space science related videos. See you in the next video. Until then, thank you for watching until the end.